Welcome to Dora Tech Essential Series. Ease your learning.
In this video, we will learn about the physical characteristics of HDD storage. HDD contain multiple platters stacked on each other with slight gap. A read/write head is placed on both sides of each platter. The spindle rotates in one direction at speed of multiple thousand rotations per minute. The actuator arm holding the read/write head can move free inside out of the platter surface. The surface of the spindle has millions of tiny magnetic fields. The difference in polarity of the field is counted as 0 or 1 for data storage. The read head reads the magnetic fields as they are. The write head is capable to change the magnetic field orientation. The spindle is divided into multiple circles, known as tracks. The tracks are further divided into sections, known as sectors. The pieces derived out of the division of tracks and sectors are known as track sectors. Each track sector can store 512 bytes of data, i.e. 4096 bits or magnetic fields. Track sector can hold only one file. We can't write two small files together. If the file is bigger, we need to use multiple track sectors to store data. The combination of multiple track sectors is known as a cluster. The storage capacity of a HDD is based on the sum of number of platters, number of tracks, number of sectors, multiplied by 512 bytes. Older drives used to have small size sectors on inner layer of spindle and bigger size on outer layer. Modern drives try to maintain the same size for each sector to increase the sectors count. Above chart shows the development and increase in storage capacity per decade. There is a slight difference between storing the data on a mechanical HDD and an SSD. A mechanical HDD cluster can be spanned into multiple random track sectors, decided by the file system. This way, a particular sector may be used more often, and prone to wear and tear. These sectors can be later on marked as bad sectors, with the defragment tool, never to be used again. The NAND flash chips used on SSD work little different. The chips are rated for number of times a cell can be changed into zeros and ones. The controller understands this and ensures no cell is used frequently. The sectors here are referred as blocks of 512 bytes. When we write the first file, it will occupy the first few blocks in sequence. The next files are written to the blocks in the following sequence. When a file is modified, it needs to be written back to the drive. NAND flash won't overwrite such data, instead it will mark the existing blocks free and write the modified file to the new block in the sequence. This way no block or cell is reused, till all the blocks are occupied to the end. The sequence will start from block 1, once the last block is utilized. Hence the given life cycle of the overall SSD increases, preventing single block failures. There are multiple form factors for SSD drives, based on protocol. Mainly SATA, U.2, M.2, NVMe, PCIe. Different kind of NAND chips are used, based on the form factors. The protocols play a key role in the speed of an SSD drive. The speed also depends on the physical port we are connecting the SSD to. Above are some speed comparisons. Hope you enjoyed this series. More to come soon. Like, share, and comment. Press the bell icon and subscribe to get notified about upcoming videos.